Certain numbers are special. They can be found by repeatedly multiplying a single number. For example, 8. We can find 8 by repeatedly multiply 2 3 times. 2 multiplied by 2 multiplied by 2 is the same as 8. Then we have, for example, 125. We can multiply 5 with 5 3 times and we will end up with 125. There are more numbers like that. For example, we have a number like 81 where we can multiply 3 repeatedly 4 times. 3 multiplied by 3 multiplied by 3 multiplied by 3 and we have 81. So these numbers can be expressed in a special form, and that form is known as the index form. So when we say the index form of a number, every number cannot be expressed in the index form, because for expressing in the index form, it has to be that special number that can be repeatedly multiplied by one number and end up with that special number. We write this special form with a little superscript. For example, we write 2 into 2 into 2 like 2 with a little 3 over here, known as the index of 2. We write 5 into 5 into 5 as 5 with a little 3 over here. We write 3 into 3 into 3 into 3 with 3 with a little 4. This little 4 that we have is known as the index, and this one is known as the base. If I write x to the power n, it means x is repeatedly multiplied n times. So that's all it means. Now there is another name for this. Another name for this is power or exponent. We can call it x to the power n or x with exponent n, or we can say n is the index of base x. If we have x added, for example 4 times, we write 4 in front and then x. We say 4 is the coefficient of x. Similarly, when we multiply x repeatedly 4 times, we write x and we write a little 4 here and we call it the index of x, meaning x has been multiplied 4 times. Suppose you have x cubed multiplied by x squared. So what would happen? Let's break this down. X cubed means x multiplied by x multiplied by x multiplied. X squared means x multiplied by x. Let's count how many x's do we have altogether. 1, 2, 3, 4, 5. That means x to the power 5. So when we multiply, we are actually adding the indices. The plural of index is indices. That's it. So from here we can write a rule that x to the power anything multiplied by x to the power anything is the same as adding the indices. Next, what about division? When we have x cubed divided by x squared, so what we have is x multiplied x multiplied x divided by x multiplied x, and we can see that these x's cancel off. We are left over with just an x. So this is the same as subtracting the indices. So we can write a rule: x to the power a divided by x to the power b is the same as x to the power a minus b. Now what about x squared to the power 3? So we have an index above an index. So this means there are x squared multiplied 3 times. So x squared multiplied x squared multiplied x squared. That's what it means. So x squared to the power 3 means x squared multiplied 3 times. So by the rule of multiplication, all we have to do is add up the exponents. So 2 plus 2 plus 2 is 6, which is the same as the exponents being multiplied. So we can write x to the power a to the power b is equals to x to the power a multiplied by b. In case of exponents that are negative, for example, x to the power minus n, we can just write them as reciprocals. X to the power n when it is a reciprocal. So 1 by x to the power n. If we have a fraction, suppose x divided by y to the power n, then both of it, the numerator and the denominator, will have the exponent as n. In case of multiplication, the same would happen. When we have x multiplied by y to the power n, we will have x to the power n multiplied by y to the power n. But this will not work in case of addition, because if we have addition, a plus b whole square, we know it is not a square plus b square, it is a square plus 2ab plus b square. So we cannot write this as simply x plus or a plus b to the power n as a to the power n plus b to the power n. This cannot be written. Same with minus. So this is very important to remember. This form only works if the variables are divided or multiplied. When we have exponent that is 0, if the index is 0, the value is always 1, regardless what number it is. If it is 2 to the power 0, it would be 1. 3 to the power 0, 4 to the power 0, 5 to the power 0, anything to the power 0, x to the power 0, it would be 1. The answer would be 1. The reason is, when we have, suppose, x divided by x, what happens if we cancel it? It becomes 1, because they're the same. Numerator and the denominator is the same. Another way of writing this is x minus x to the power 1 minus 1, because this has an index of 1 and this has an index of 1. So we know this rule that division is subtracting the exponents or index. So when we do x to the power 1 minus 1, it becomes x to the power 0. So it's the same thing. So in a nutshell, some numbers can be written in a special form known as the index form. And that form is written by two numbers. There is a base and there is a little number over here. The base is known as the base, and this number is known as the index or the exponent or the power. We usually call it x to the power n. It means x is repeatedly multiplied. When we want to simplify that, we can simplifying, when we multiply this, we add the indices. When we divide, we subtract the indices. When we have index above the index, we multiply the indices. Then when we have negative index, it's a reciprocal. Then when we have division and a common power, we can write them with the individual power for each. And same with multiplication. When we have x into y to the power n, it would be x to the power n multiplied by y to the power n. Now these are rules for simplifying. Now there are certain rules by which we can solve an equation. For example, when we have an equation where we have two index, x to the power a equals to x to the power b. So since the bases are equal, we can just write a equals to b. So this is a rule for solving any equation using the index form. Another rule would be when we have x to the power a equals to y to the power a. Since the indices are equal, we can just write that the bases are also equal. And finally, when we have, suppose, x to the power a equals to another number and we want to find the base, in that case, we send the index to the other side as a reciprocal. It would be b to the power 1 by a. Now a trivia question. Somebody asked Mr. Euler. By the way, Mr. Euler was the person who gave the symbol for pi. Previously, no one came up with the idea for using a symbol. So anyway, somebody asked him, how many numbers are there that are both a square and a cube? For example, there's a number like 64. He said 64 is both a square, 8 square, and a cubed, 4 cubed. So he said, is there a way of knowing how many numbers exist like that, that are both a perfect square and a perfect cube? And Mr. Euler said, in a second, there are infinite numbers like that. And he said, how do you know? He said, well, any number to the power 6 is actually both a square and a cube. So since 64 is 2 to the power 6, it is both a square and a cube, because we can write x cubed whole square, which turns out to be, if you multiply 3 into 2, 6, or we can write x squared whole cubed. If you multiply 2 into 3, it becomes 6.